Hello. Okay, well, it doesn't look like there's anybody here. I was just waiting a second to see if anybody would pop up. Let me see. No, it's just me. All right, well, I'm going to go ahead and record, and I'll just go ahead and talk about Module 4 and a bit about the test 1. That's pretty much it. And hopefully people will come in, they'll watch the the recording. All right, let's go ahead and get started. All right, so as you can see, there was one scheduled for today, January 27th. I'm just a little bit shocked that there's nobody else here. So we're looking at the Module 4. It's not Test 4, Test Module 4, sorry. Module 4. And the best thing you can do, I think, is to go through the Module 4 soft chalk. That will help you with the material the most, I think. I wanted to point something out with the Module 4 assignment. There are a number of questions here. I'll show you them in a second. Just a very small amount of background here before we get started. Hello. I'm glad someone else is here. I was gonna do this on my own, but I'm glad you're here. Thank you.
I'm trying to fix some of the things here. I'm not too familiar with this.
Yeah. What's your first name? Is it Christian?
Yes.
Yeah, that's what I thought. Okay. Okay, good. Thanks, Christian. Appreciate you being here, buddy.
Oh, no, thank you for hosting.
Okay, so we were looking at the density lab here. Density is mass divided by volume. We can also rearrange this and we can have mass equals density times volume, and we can have volume equals mass divided by density. So mass will always be in grams and volume will be in milliliters or possibly cubic centimeters. Milliliters for liquid, and then cubic centimeters for solid. So when we're looking at some of these questions, you'll notice the first one here gives in the mass in kilograms, and you are required to convert that into grams first because it's always grams over mils. Grams over mils or cubic centimeters. This one's given in cc's as the volume, and that's fine. But I wanted to point out ones like question 3 here. you'll notice that this is looking for a mass, and mass is density times volume, but you've got to remember that if it's density times volume, mass can also equal volume times density. So it can go either way. So you need a way to be able to distinguish between answer 1 and answer 2, whether it's volume or density. And what I've done here, I said this is multiplication, so number 1 already has been set equal to something, please solve accordingly. Number 1 has been set to the volume, which means number 2 must be the density. So I want you to keep that in mind when you're solving some of these Module 4 assignment problems.
I came across those the first time and it had me confused on why I wouldn't go with the flat answer versus the grams over milliliters, but I figured it had to go with canceling out the units.
And that's right. Yeah. So you're okay with these as they stand though, right? With the times in them?
Yes.
Okay, that's good. And for the rest of them, well, let's say we've got number 7 here. We've got to be a little bit careful here because if this is a cubic shaped object, 12.4 centimeters on each side, that means it's 12.4 times 12.4 times 12.4 to find the volume. I'll go ahead and write that in. Which is going to come out, I think, to 1906.624. Now, we don't do significant figures on this because it's all multiplication, division all the way through this problem. So we're going to keep all these significant figures until the very end when we cancel it down to 3. And that's based on the 12.4 here, which has 3 significant figures. So the answer comes out to 3 significant figures as well. But the 12.4 by 12.4 by 12.4, then those need to be in order. So this will be 1, and this will be 2, and this will be 3. And then we do, that's number 4, number 4 is the answer, which is, there's 2 instances of this answer. You've got 1 here, that's number 2, and down here that's number 1. So that's the first one we use. So that'll be, that's what goes in answer slot 4. Then answer 5, that will be the mass. And answer 6 will be the second instance of the volume that we calculated. And then the other, everything else is unused, and you have to put a number 7 in that. So anything that's not used is an unused answer. You have to put the 7 in. You can't just leave it blank. That's how we'd solve a problem like that. Does anybody have any questions?
I felt fairly good on module 4 there. Yeah.
Okay. All right. So I'm going to go through the module just a little bit, not very much, just a little bit here, especially about significant figures. I think that's going to be important here as we go through. Oh, looks like somebody else popped in as well. Okay, thanks, Isra. All right. Let's see, module 4. Okay, so the main issues I wanted to talk about here have to do with, first of all, just 2 examples I want to go through. We talked about this just now, but when you're dealing with a situation where you're looking at the volume of a cube or the volume of a prism or a rectangular block, we don't deal with significant figures until the very end. And then the significant figures in the final answer will always be based on the smallest number of sig figs that you see in the question. So 2.1 centimeters, that means 2.1 times 2.1 times 2.1, and we figured this out to be 9.261 cubic centimeters. That's what it comes out to in your calculator. We keep all those significant figures, and then at the very end we cut it down to 2 significant figures, which is what we've done here. Does anybody have any questions? Now this is all because it's all multiplication and division. Now contrast that with this kind of question where we've got 12.3 milliliters of water in a graduated cylinder. We put a stone in there and the volume reads 15 milliliters. Now in this instance, we're dealing with a subtraction in order to get the volume first. So the volume of the stone, I think it's going to be clear, is going to be 15 mils minus 12.3 mils. And if we were to put that in our calculator, it would come out to be 2.7 mils. But if we bring this to significant figures, it'd be 3 mils. Now the reason for that is because this is a subtraction, so it's based on 0 places past the decimal point. And this is 1 place past the decimal point. So the answer here comes out to be 0 places past the decimal point. In this case, we're mixing operations because in the next step, we take the density, which is going to be a division, which is mass divided by volume, which is 6.34 grams, divided by what we got up here in the 3 mils, which leads to 1 significant figure at the end, which is 2 grams per mil. So this is a bit confusing because anything that involves a mixing of operations, we need to get the sig figs from the first operation, which is subtraction, and then deal with the significant figures we're getting from the multiplication division. I want you to contrast this with the previous problem where all of this is multiplication and division. So we don't deal with the significant figures until the very end. And in that instance, we're just using what we're getting on in the problem to figure out the significant figures at the end. So that's the difference between the two problems. Does anybody have any questions?
I'm like confused about the whole idea of like significant figures.
Isra, I'm not sure how to respond to that.
Cause like sometimes there's like some calculations where there is no decimal point, even though like the original equation has some decimal points. And like when to round up to a number, like if there's a like 13.98, do you like round it up to 14?
Well, it depends. The answer is to that question is it all depends. I mean, can you give me a specific example that confuses you?
Um, I'll have to look for that.
I'll tell you what, Isra. Let's hold off on this for now, and I'm going to go through sample test. I'm going to go through the true test 1 in a little bit. Maybe we can figure out some problems from there and then apply significant figures rules to those problems. Would that be okay?
Okay.
All right. So if you can find another example you want to go through, we'll certainly do that. But for now, let's soldier on through what we're doing here. So that was the main thing in Module 4, was to be able to distinguish the significant figure issues we're facing in Example 4 and Example 6. Does anybody have any other density questions, Module 4 questions that they're interested in getting answered at this point?
Yes. When it comes to the 10 decimal milliliter versus
Yes.
10 milliliter, I
Yes.
get that there's a major difference when considering rounding and inaccuracy, but does
Right.
that also apply to a question where it'd be like 6 milliliters?
Well, it depends. Let's see. So if you've got 10 dot versus 10, I have a video about this where I explain that the 10 dot is the result of rounding a number that lies between 9.5 and 10.4, whereas 10 mils results from rounding a number between 5 and 14. So the accuracy of these two numbers is what's in question here. The dot is making this zero significant, whereas the lack of the dot here means the zero is not significant. And that's why it's important that if it's written down as 10 dot, that's how it's presented as well. But your question was about 6.
Yeah, if there's like a 6 versus a 6 dot.
Well, there's no difference between those. The only time that the dot really matters is when you've got 0 as the final number, and you're trying to determine if it is indeed significant or not. I mean, if it was 11, there'd be no question. We'd know that 1 was significant. But 0 here, we don't know if it's significant unless we include the dot here, and that's the issue we're facing. Is that okay?
Yeah, that's perfect there.
Okay, so for non-zero digits, it doesn't really matter. Isra, did you have any questions about this? Because I know that this might be part of what's confusing you with regard to significant figures as well. Isra? Isra, did you have any questions about that?
Not currently.
Okay. Anybody else got any other density questions? Okay. What I'd like to do is go through the test 1, and Isra, I haven't forgotten about you. I will be talking about significant figures as I go through some of these examples. So first of all, let's talk about test 1. The test 1 study guide is at the top here and gives you an idea of the question types that you'll see on the actual test. I want to point out here that if we've got something like number 3, you can see it's a range of different questions that could be for number 3. Likewise, number 5 is ordering, but it's based on electronegativities, ionization size, ionization energy, or size. So any one of those questions could appear for number 3, and then any one of those other questions could appear for number 5. And what will happen is you'll be taking this sample test, or practice test is really what it is, and each time you'll see different kinds of questions pop up in these categories. But you can see it's very clear about what kinds of questions you're going to see as you go through them. So we've got modules 1, 2, 3, and 4 obviously covered here. Does anybody have any questions about the study guide?
Not for the guide itself, but
okay.
Just some questions about the test, and like I read through the syllabus, but I wanted to double check some things.
Okay. Well, so let's talk about that then, Christian. What questions did you have?
So we'll have a periodic chart and a formula table.
Let's go ahead. Let's go ahead and open up the practice test. So what you'll see in the practice test is exactly what you'll see in the real test that you take. The real test will just be the practice test. It's the same test. There's no difference between the two, and you'll have the same you'll have access to the same materials in the real test as you do the practice test. You'll have a periodic table. You'll have a list of elements and symbols. You'll have a conversion sheet as well. All right, this will all be in the real test that you take as well. Is that okay, Christian?
So it's filtered in the questions there?
It is, yes.
Okay.
So you won't need to have those sheets printed, and I don't want you to have them printed. The only thing I want you to have with the test is a piece of scratch paper, blank.
Yep.
All right, so if we look at the questions here, the question 1 was the diagramming of electrons, so that's not going to change. Question 2 will be an ion question. That's not going to change. Now, question 3 was from a range of different things. You can see this one's about the period number, but it could be about the group number or valence electrons or where it is in the periodic table, that kind of thing. And the way that you would study for this is to just take this practice test over and over. And my advice is to take the practice test under the same conditions as you're taking the real test, which means you take it closed book. And you do so until you're getting at least 90% on the practice test. If you're getting 90% consistently on the practice test closed book, I can't see how you'd fail the real test. Because the real test is the same as the practice test. Does anybody have any questions so far? Now, if you take the practice test and you get 80% before the test is, well, the day before the test is due, which I think is February 5th is, I think, when I've got the test due by, and the extra credit here for this is going to be due on the 4th. So if you take you take the practice test, you get 80% on that. You can get an extra 5 bonus points, which I think you should take advantage of. I mean, you have to take this test anyway to study. Why not take it and get 80% before the due date? All right, so we've got all those, and then you've got the same. These are the same kinds of questions as you've seen while doing the assignments and the practice and credit quizzes that we talked about earlier. All right, so the same kinds of questions. So I'm going to go through a couple of these with a special emphasis on the significant figures. So for this one, diagramming an atom of chlorine, what you would do is you would find out where chlorine is on the periodic table. And you can see here it's over on this part of the periodic table. 1, 2 in the first row, and it matches the elements. I do videos on this as well. So we've got 2 electrons in the first row, 2 elements in the first row, 8 elements in the second row. Sorry, 8 electrons in the second row, 8 elements as well. And then to get to chlorine, it's 7. 1, 2, 3, 4, 5, 6, 7. So the answer there would be 2, 8, and 7. And that's what you'd put in those blanks. Does anybody have any questions so far? Radium has 2 valence electrons. 2 valence electrons means it's going to be a 2+ charge. Any questions about that one? Okay. Period number for IN. So you go back up, find out where IN is. Let's see, IN is, where is it? There it is. So it's in period, which is the row. 1, 2, 3, 4, 5 would be your answer there. Remember, that question could be anything in that list that's in the study guide, so just keep that in mind. The electronegativities, and we're looking at P and Cl. Look at where they are in relation to each other on the periodic table. P and Cl are both in the non-metal section. So I would say that that would be polar covalent. If you want more about this, you'll have to go back and look at the theory on it when you're studying it. Smallest to largest, so we're talking about atomic size there, Cl, Mg, and Al. So Cl, Mg, and Al, they all happen to be in the same row. Size decreases going across the row, so it goes Mg, Al, and Cl. Mg is the biggest, Al is the second biggest, and Cl would be the smallest. And accordingly then, if Mg is the biggest, we're going from smallest to largest, so largest is 3. Al would be number 2, and then the smallest would be number 1, which is Cl. That's how you would order it. Does anybody have any questions about number 5? We have someone else pop in here. Joel's here. Thanks for coming, Joel. Now you've got the conversion chart here, so you will just type in. This is exactly what you would have done during the homework for module 3. You've got number 1 and number 2. We're looking for meters into centimeters. So we know number 1 is going to be centimeters, so it'll be 100 centimeters. Again, we get that off the conversion chart. Just type it in directly as it appears. 1 meter. Now, if it's looking for something a little bit more complicated, you'll put the entire number in here without the dots. And it's the entire number. That's to take significant figures into account. So this one has 3 significant figures, 18.9. So the answer is going to be, let's see, we're looking for centimeters here, 18,900 centimeters. Now we don't put a dot on there, because if we put a dot on there, we'd make those zeros significant. And we don't want to do that. Hang on, let's try that again. 1890 is what it would be, sorry. And there's no dot on the end there. Any questions? Any questions? Isra?
Yes.
Did you have any questions about the sig figs on that one?
No.
The 100 and the 100 centimeters and 1 meter are not subject to significant figures because they're counting numbers. And we know that because they're exactly as they appear here. So for the next one, we're going from liters to milliliters. So we know that 1 is 1,000 milliliters. We know that 2 is 1 liter. And we're trying to get it into milliliters. We divide that by 1,000 and we'll get, multiply it by 1,000, we'll get 3, 4, 2, and we do need 0.0 here because the number of sig figs in 0.3420 is 4. The 0 counts here at the end, but it doesn't count at the beginning. So the 0 here at the end does matter for significant figures, which is why it's 342.0 as our answer. So Isra, I'm just asking you because you had significant figure issues, and I want to go through each one of these and make sure that you understand each one with significant figure implications. Do you have any questions about this one?
No, I understand that one.
Okay, good. Does anybody have any questions so far? Okay. So this one, we're going from liters to pint, which is going to require a 2-step situation. So we go back up to the thing here and the conversion chart, and we've got quarts into pints and we've got liters into quarts. So we know that we're going to have to type this in entirely here, 1.0566882. So 1 liter will go on the bottom. sorry, 1 quart will go on the bottom. And I think it's, let's go back up to it again and make sure I get this right. Now 1 liter goes on the bottom. And 1.0566882 quarts is what goes in slot 1. Does anybody have any questions? Now we're looking for pints, so I think it's 2 pints to a quart, 2 pt, 1 quart. And then we come up with our answer, and our answer is going to have 3 significant figures. So let's see, I'll have to bring up a calculator for this one. And the answer should come up to 262. That doesn't seem right. No, I suppose it does. Yeah, 262 pints. That would have 3 significant figures. Does anybody have any questions?
Not about that problem, but could you show me what the honor lock calculator looks like?
Well, I think in the thing, did I say you have to use the honor lock calculator or not?
I believe so.
Okay, I'm actually going to change that in the syllabus to saying that you can use a handheld calculator, but it has to be a handheld calculator. It can't be a cell phone. But the honor lock calculator, I'll show you what that looks like. You actually have access to it in the practice test, and that's what it looks like there. I'd recommend opening it in a separate tab if you're going to use that and practice with it.
Is this sort of one okay?
I'm sorry?
Is this sort of calculator approved, or?
Okay, let me see. Let me see what you're looking. I want to see what you're looking at. Okay. Yeah, that one's okay. If you want, and I mean, I'm going to put this. I'm going to change this in the syllabus. I'll send something out as well. But I was able to put it in honor lock that you can use and in the honor lock directions, it states now that you can use a handheld calculator.
So like about the question we just did.
Yeah.
Why do we only have 3 significant figures and not use like the numbers after the dot?
Okay. So this number we start with has 3 significant figures, Isra. And this one has 1, 2, 3, 4, 5, 6, 7, 8. This one has 8 significant figures. So the answer can be no more accurate than the least accurate number used, which is what we're starting with. These don't matter for significant figures, they're counting numbers. So we end up getting 3 sig figs at the end.
So like we use the least.
Yes, yeah, because the rationale is that you can't have an answer that's more accurate than your least accurate number. And the least accurate number is the one with the smallest sig figs.
Okay.
Is that okay?
Yeah.
Okay. Do you have any other questions about that question?
No.
Okay. So this one is going from liters to gallons. So Israel, I'm going to test you on this one. You should be able to tell me immediately how many sig figs the answer will have.
4.
Yep, 4, just based on what you're seeing here. All right. So I won't do that one, but you've seen it's very similar to what I did over here. And this one here, this is a temperature conversion question. You have the temperature conversion equations, they're here in the actual conversion chart, so you don't have to memorize them. You'd go through, and for this one here, we're taking 95.0 degrees Fahrenheit into Kelvin. And the answer there is going to be, let me think, 95, I'm just doing the math here. yeah, it's going to be close to 308. But you'll notice there's a number of answers here that are near 308. You've got 308, you've got 308.2. You have to know which one you're picking. And it's going to be based on the number of places past the decimal. This is because this is an addition subtraction problem that we're dealing with temperature conversions. So it goes by number of places past the decimal point. So this one has one place past the decimal point. Your answer would have one place past the decimal point. So it'd be 308.2 and not 308. Does anybody have any questions about that?
So that would be one where we have to put it in Celsius first and then convert over to Kelvin?
Yeah. Now, if you did that, it'd come out to be, oh, I don't know, about 35.2 or something like that degrees Celsius. And then you would add 273.15 to it. And then, sorry, it'd come out to be like, I think it comes out to be 35.0, and then you add 273.15, and it comes out to 308.2 once you round it. All right, any other questions? Okay. So for this one here, this is the mass of a, we're going to find the density of a liquid. And first of all, we need to find the mass of a liquid, which is going to be 47.50. And you have to type in the whole thing. You just can't type in 47.5 because that's what you're given. And then you've got 30.00 grams. The difference between those would be 17.50 grams. And this goes by number of places past the decimal. So we've got 2 places past the decimal, 2 places past the decimal. So the answer comes out to 2 places past the decimal. Isra, are you okay with this so far?
Yeah.
Okay. So number 4, that's going to be the mass. Not the mass. Yeah, the mass that we just did, which is going to be 17.50 grams. And then we've got a volume here that we've been given, which is 17.00 mils. So the number of sig figs here is going to be 4. So when we do this division, let me put in my calculator here. 17.5 divided by 17. We get 1.029, so that should be the answer. That's going to have 4 significant figures. That's 1.029 grams per mil. So it's going to be decided by the significant figures that we get here. This is a mixing operations type situation. Does anybody have any questions? So the next one, we've got a prism, and those go in order, length, width, and height. So you just plug them in the order that they appear here. So 10.0 centimeters. Again, it has to be 10.0 and just not 10. 3.0 centimeters. And 2.0 centimeters. Now for this one, you don't want to short yourself on the significant figures. So take this out to whatever significant figures you get from that. 10 times 3 is 30, times 2 is 60. So I know it's going to be 60.0 centimeters here on the centimeters cubed on the units. Now you might be saying, well, why didn't I do significant figures here? Well, this is because it's all multiplication and division. I'm going to take those into account at the end. So the mass here is 280.00 grams, and the volume is what we just calculated here, 60.0 cm3. And then we do the math on that. and I get 4.67, and that would be 3 significant figures, 5 significant figures divided by 3 significant figures. But unfortunately, we've got to go back and look at the problem here and come up with what has the smallest number of sig figs, and it's 2. So it's not going to be 4.67, it's going to be 4.7. That'll be the correct answer there, grams per cubic centimeter. It's a bit tricky, isn't it? Does anybody have any questions?
The test won't be this short, will it?
Yes.
Okay.
I mean, that's it. That's all there is to it. I mean, if anybody's going to fail this test, I mean, I'd be really surprised. I mean, you know, I told you it's the same. The test you're taking is the same test. I don't think it's that big a deal, honestly. I think it's, you know, it's not really that challenging. Isra, do you have any questions about the sig figs on that one?
No.
Okay.
So like you said it was only one place because of the 2.0 cm.
Yeah, that's right. Yeah, so actually 2 significant figures is really what I'm saying, because that's 3, that's 2, that's 2, and that's 5. So the answer comes out to be 2 sig figs.
Yeah.
Okay. Joel, you there, buddy?
Yeah,
Joel?
what's up?
Did you have any questions?
I do not.
Okay. All right. Well, does anybody have anything else that they want to add for the good of the order? Any questions? All right. Well, good luck, folks. Good luck with getting Module 4 done, and then the test is due next week. So make sure you get the practice test done and get the extra credit on that. Remember, the real test can be done anytime up to the due date. You could do it tomorrow if you wanted.
Okay.
Yeah. All right. So I do appreciate you all attending the Zoom meeting, and I wish you the best of luck. If you need any help, be sure to reach out.
Thank you.
All right. Thank you.
Thank you.
Yeah.
All right. See you all later.